Ever wondered why traditional monolithic systems often struggle with scalability and coupling issues? Well, let's take a moment to break it down. Traditional monolithic systems are like a tightly woven fabric where each thread is interconnected with the rest. Everything is bundled into a single, unified system. While this might sound efficient, it's this very structure that gives rise to the challenges of scalability and coupling. Scalability is tricky because any change made to one part of the system can ripple across the entire structure, causing unexpected complications. The tightly coupled nature of monolithic systems means that individual components are dependent on each other. This interdependence can lead to a lack of flexibility and increase the risk of system-wide failures. These challenges can severely impact the performance and efficiency of an application, slowing down progress and limiting innovation. Luckily, there's a more efficient alternative to monolithic systems: microservices. So, what exactly are microservices? Well, imagine a city. This city represents a complex software application. Now, in a traditional setup, you'd have a single governing body running the entire show, from traffic control to utilities management. This is akin to a monolithic architecture, a single, indivisible unit that handles all functionalities. But a city managed this way can become unwieldy and sluggish, especially as it grows and evolves. Now picture the same city, but this time, it's divided into several self-governing districts, each performing its own specific tasks. Traffic control is handled by one district, utilities by another, and so on. This is what microservices are all about. In the realm of software architecture, microservices is an approach where an application is created as a collection of small, autonomous services. Each microservice is a self-contained unit that performs a single function, whether it's handling user authentication, processing payments, or managing database interactions. Here's the beauty of microservices. They work independently of each other, allowing for decoupling. If a specific service needs to be updated or modified, it can be done without disturbing the entire application. This separation also means that if one service fails, the others can continue to function, ensuring that the whole application doesn't grind to a halt. Another advantage of microservices is their scalability. Since each microservice can be developed, deployed, scaled, and updated independently, it's possible to scale up or down based on the demand of individual services. For instance, if an e-commerce platform sees a surge in user registrations during a sale event, the user registration microservice can be scaled up to handle the increased load without having to scale the entire application. In summary, microservices architecture breaks down a complex application into manageable, autonomous units, providing the flexibility to modify, scale, and maintain each unit independently. This approach offers a powerful solution to the scalability and coupling issues that often plague traditional monolithic systems. Microservices offer a solution to the scalability and coupling issues that plague traditional monolithic systems. Let's delve deeper into how microservices enable decoupling and scalability. To start off, decoupling in the context of microservices refers to the independent operation of each service. This essentially means that each microservice stands alone, carrying out its specific function without being tied to the operation of others. It's like having a team of specialists, each with a distinct skill set, working together but independently to solve a complex problem. This independence is a game changer in software development. Why? Because it allows for changes or updates to be made to one service without impacting others. Picture this. You're running a marathon and you need to change your shoes. In a decoupled system, you can change your shoes without having to stop and change your entire outfit. Similarly, in a microservice architecture, if one service requires an update or a fix, it can be done without causing a ripple effect on the other services or the overall system. Now, let's talk about scalability. In traditional monolithic systems, scaling often means duplicating the entire application, which can be resource-intensive and inefficient. However, microservices offer a more elegant solution. Each service can be individually scaled based on demand. To draw a parallel, Imagine a city where traffic is managed by scaling up the number of buses during peak hours and scaling down during off-peak hours. In the same way, a microservice that's experiencing high demand can be scaled up independently, while those with less demand remain as they are. This not only optimizes resources, but also enhances the overall performance of the system. So, in essence, the principles of decoupling and scalability in microservices provide a robust and flexible architecture. They allow for independent operation and evolution of services, efficient use of resources, and a responsive system that can adapt to changing demands. Microservices, with their decoupling and scalability, can revolutionize how we build and manage applications, providing a robust solution to the challenges posed by monolithic systems.